Alright, let us do a couple more problems from the book. We are still on section 8.1. The first one is 0 to pi, okay, sine squared t cosine t dt. So it is a definite integral because it has a limit of integration, right? So how do you do this problem is, let's set actually, you know how to do problems, the methods or the procedures for fitting integrals to basic integration rule is given on page number 519 on your book. Okay, it will basically tell you, if you see this type of problem, what formula should you use? If you see that type of problem, what formula should you use? That kind of thing. Okay, they are giving you the methods, all right, procedures. Okay, on this problem I'm going to set u substitution, that is sine t equals to, I'm doing u, then what we'll get, cosine of t dt equals to du. Okay, so what do you get here? Then you will get sine squared t cosine of t dt becomes u square du, right? You got u square du here. You see that? Now what would you do? What is the integral of u square du? That will be u cubed over 3 plus c. Now what I'm going to do is I'm coming back to the sine. Okay, I got 1/3 sine of cubed. You see that? Sine cubed t plus c, or whatever you want to do there. Okay guys, so what do you get is, so that is plus c, right? But what is the limit though? If you plug in the limit, hence the 0 to pi sine squared t cosine t dt equals to 1/3, right? And then sine cube t, you don't need plus c, okay, because that will cancel out. So 0 to pi, you just plug in. If you plug in pi, you'll get 0, and then minus, if you plug in 0, you'll get 0. Basically this will be 0. But one of the very important thing you should think about this problem is, if you draw the graph of this problem between 0 and pi, this is 0, this is x-axis, this is y-axis, okay, it will look like this. This is, let's say this is pi, okay, it will look like this. Okay, if the question was asking to find out the area, then you would have to find out this area separately and then plus that area separately. This is 0 to pi half and then pi half to pi. You need to do that separately, but it is not asking you to find out the area. It is just asking you to find out the integral. The integral is 0 because the area on the upper region is positive, and area under the below region, that region will be negative. So negative plus positive, positive plus negative will be 0. They will be equal but opposite sign. That's why the integral is 0. But if the question was asking you to find out the area, then you will have to do 0 to pi half and then pi half to pi separately and then add them, add the area. That's what you needed to do if it was asking to find out the area. Okay guys, so but this was just asking to find out the definite integral, so it is okay to write 0 there. All right, now next question is number 68. So you need to find out 2 to 4, there is 4x cubed and then over x to the 4 minus 6x squared plus 9. You see that the denominator has a 4th degree, the numerator has 3rd degree. So if you set the whole denominator equals to u, then you might get that du thing, right? Let us do that. So what do you get? You get basically set x to the 4 minus 6x squared plus 9 equals to u. Then what is the derivative? 4x cubed minus 12x dx will be du, right? But we don't have negative 12x. How do I do that? Then I can write negative 12x positive 12x like that, right? Negative 12x plus 12x, I could write that way. Okay, let us try that way. So the integral is 2 to 4. I can write 4x cubed minus 12x, okay, and then plus 12x, and then dx is there, divide by, I can write x to the 4 minus 6x squared plus 9. I can write like that. Let us split Okay, so that is equals to 2 to the 4x cubed minus 12x over x to the 4 minus 6x squared plus 9 dx, and then plus integral 12x over, you can write x to the 4 minus 6x squared plus 9. You can do that, and then dx. So on the first integral, it is basically that there is a function in the denominator whose derivative is in the numerator. That means it is log, right? Because we know that integral of u prime over u dx will be natural log of u. It's like that, right? There is a u on the bottom and then u prime is on the top. So there is a dx, so it will be natural log of u, right? Natural log of the denominator. So what I'm going to do here is I'm doing natural log of the denominator will be x to the 4 minus 6x squared plus 9. And the limits are what? The limits are 2 to 4, right? 2 to 4. And plus, on the second integral, there is 12x on the top. On the bottom, can you simplify that? I think you can write like x squared minus 3 square. Like that. Dx. You see that? Because we need two numbers, because there is x to the 4th x squared. If you set x squared equals to u, then you will get that format, right? U squared minus 6u plus 9, that will be u minus 3 squared. That's what you can think. Okay, so that's the way that you can write the completing the square, you can think of, right? Like that. Now we need to do u substitution here as well. So we'll do x squared minus 3 equals to u. Okay, guys. All right. I'm sorry that it is messed up a little bit, the size, but it's okay. All right, so let us plug in 4 here. 4 to the 4 is how much? 256, right? 4 to the 4 is 256. Let me use calculator. We'll have to plug in that natural log thing. So you get natural log of, let's plug in 4. So 4 to the 4 and then minus 6 times 4 squared is 16 and then plus 9. Okay, so what do you get? 4 to the 4 and then minus 6 times 16 plus 9. You get 169. Natural log of 169. And then minus, let's plug in 2. Okay, natural log of 2 to the 4. 16 minus 6x squared is 6 times 4. So it is 24 plus 9. Okay, 16 minus 24 is negative 8, right? 16 minus 24 is negative 8, and then plus 9 is 1. Natural log of 1 will be 0, right? So we will not worry much about that, right? Because that will be 0, right? And then plus, what I'm doing is here, I'm taking 12 out, right? 12 out here. And then x over x squared plus 3 to the square and then dx. If you said x squared equals to u, then 2x dx will be du, right? So it will be x dx, then that will be 1/2 du, right? That will be 1/2 du. By the way, that is 2 through 4, right? That is 2 through 4. Now you can change the limit of x into u, or you can plug in back later, not a problem. Okay, so either way that will be fine. So what do you get here then? That will be so you get x dx over x squared plus 3 to the square. That can be written as, you can write x dx is 1/2 du over u square, right? Basically you get 1/2 and then u to the negative 2 du, right? If you use the integral, what do you get? You get 1/2 u to the negative 2 plus 1 over negative 2 plus 1. That is negative 1/2 1 over 2u. That's what you get. Negative 1 over 2u, because u to the negative 2 plus 1 will be negative 1. If you move that to the denominator, you will get just u in the bottom. You see that? Okay, so that is negative 1 over 2u. Basically, if you plug in back the value, then you will get negative 1 over 2x squared. That's what you get. Okay, let's use that thing. Natural log of 169, right, and then plus 12 times negative 1 over 2x squared, but the limit is 2 through 4. That's what you do. Okay, guys, so how much is that? That will be 6. So it is 100. Natural log of 169, right, and then minus, with 6 times negative is minus 6. Let's plug in 4. That will be 1 over 4 minus 1 over 2. Not really. 1 over 16. 4 square minus 1 over 2 square, right? That's what you get. Because if you plug in 4 first, it is 4 square, and then because I pull that negative sign here, right? And just, or you can use calculator to find out that, not a problem. So what do you get? You basically get natural log of 169, right? And then how much is that? 1 over 16 minus 1 over 4. Okay, so that is negative 6 times 1 over 16 minus 1 over 4 is 4 over 16. So negative 3 over 16. That is basically 6. You can write 6 times 3 is 18 over 16. That is 9 over 8, right? Natural log of 169 minus a plus 9 over 8, because there will be double negative. That is the final answer. Okay, guys, that is the final answer. All right. So the next problem that I'm going to do is question number 75. It is asking to find the area, not only find the integral, it is asking find the area. Okay, you see that it is y square. So if you solve for y, you will get plus and minus. Okay, so plus and minus, and then you write x, and then under the root 1 minus x square. You'll take square root on both sides, right? When you take square root, you need to take plus and minus. And you might be curious how the graph look like. The graph for the plus will be above x-axis. That will be the graph for the plus, that one. And graph for the minus sign will be the bottom one. You see that? So to find out the area, you can find out the graph of the plus sign, that upper part, that the area on above that, you can find that area plus that area. Okay, and then multiply by 2. That is perfectly fine. Okay, so what you can do here is take the positive one, because the bottom part and the top part are symmetric. Okay, this graph is symmetric about both x-axis and y-axis. So you see that if you replace x by negative x, you will get the same equation. If you replace y by negative y, you get the same equation. Okay, so it is symmetric about x-axis and y-axis. So in fact, if you want to do the easier, again shorter way, you can do just find the area of this part, that part, okay, and multiply by 4, because it is symmetric. That area is equal to this area is equal to that area is equal to that area. So all these pieces have the same area. So what you can do is you can write the area equals to, you can write 4 times 0 to 1, right? 0 to 1, and then that x under the root 1 minus x squared dx. You can do that. You can multiply by 4 and then times that area, or you can do 2 times this area plus that area. That's the same thing, not problem. Okay, all right, so this is basically easier. So what I need to do is I need to substitute that as u. Okay, set 1 minus x squared equals to u, then negative 2x dx will be du. So x dx will be negative 1/2 du, right? So what is the integral then? Then the integral will be integral x under the root 1 minus x squared. I'm not thinking the limit. I will plug in the limit later. Okay, I'm just not taking 4 as well, but I'll write that 4 later. Okay, so equals to, what do you get? You get so dx. Okay, so x dx, x and dx will become negative 1/2 du, right, times that is basically root u. Okay, so what you get basically is, so that is negative 1/2 integral of u to the 1/2 du. That will be how much? Negative 1/2 times u to the negative 1/2 plus 1 over negative 1/2 plus 1. Okay, what I'm doing here is basically, how do you get negative 1/2 plus 1 is positive 1/2, right? U to the 3/2 negative 1/2 is on the front, and then divide by positive 1/2. That 1/2 and 1/2 cancel out. That is negative u to the 3/2. Therefore, hence I can write 4 0 to 1 x under the root 1 minus x square. Okay, dx. So by the way, how much is that? Negative 1 minus x square to the 3/2, right? Is equals to 4 0 to not the integral, because I'm coming out of the integral. I will plug in that one. So I can write, let me write down like okay, I want to write like this: 4 and then 1 minus negative 4, right? Because there is a negative sign there. Negative 4 1 minus x square to the 3/2. But what are the limit? 0 to 1. Okay, now plug in 1 first. What do you get? Negative 4, plug in 1. 1 minus 1 is 0, right? Times 0, 0 to the 3/2 is 0. And then minus negative 4 times plug in 0. What do you get? 1 times 1. Right? What do you get? That is positive 4, because that is 0, negative, negative, positive. So the total area is 4. The whole area is 4. Only this part will have area 1. That is 1, that is 1, that is 1. So the total area is 4. That's how we find out the area. Okay, guys? Alright, that's the end of the video for section 8.1. Thank you, guys.